Good morning, everyone. Now we'll see few methods how to calculate bond order. BO. So BO is nothing but bond order. The bond order can be defined as the number of bonds between the atoms in a molecule. For example, let's see, I'm writing CH3, CH3. If I write this structure clearly, I will get like this. So the bond order between carbon and carbon is 1. That is the number of bonds between carbon and carbon is 1. So here what I am going to discuss is the structure. How can you calculate bond order? To calculate bond order, we have different methods. That one, first one, the bond order is equal to number of sigma bonds plus pi bonds divided by sigma, or 1 plus pi by sigma. Okay. Now, for example, I'm taking a molecule. Now, we'll discuss this one by taking an example. See, I'm writing CO3 2 minus carbonate ion. So I don't know the structure of this compound, but I'm trying to write possible structures for this one. So this is the possible structure for this one. See in this one, how many sigma bonds we have? So the bond order is equal to 1 plus number of pi bonds, that is number of pi bonds is 1, number of sigma bonds is 3, that is the bond order is 4 by 3. And if you take benzene, so the resonating structure of benzene is like this, you can write. So for benzene, we have 2 resonating structures. See in these 2 resonating structures, the bond order is how many sigma bonds and how many pi bonds we have, see. So that is 1 plus number of pi bonds is 3, number of sigma bonds is 6. So that is 9 by 6. The bond order is 1.5. Similarly, to calculate bond order, we can use one more formula. So the bond order is equal to number of bonds between any two atoms in all resonating structures divided by total number of resonating structures. So here I am taking again carbonate ion as an example. Carbonate ion. So the possible resonance structures are C double bond O, O minus, C double bond O, O minus. So this is the one of the resonating structure. If the negative charge migrate like this, and here we will get one more resonating structure. The resonating structure is like this, and again this migrate like this, and here this pi electron will migrate like this, and CO minus, double bond O, single bond O minus. So the possible resonating structures are, I have three possible resonating structures. In these possible resonating structures, number of between any two atoms. So now we have to calculate the bond order between carbon and oxygen. So sum all the bonds between carbon and oxygen. C2 plus 1 plus 1. So that is total number of bonds is 4. And total number of resonating structures is 3. So the same thing what we got here, here also the same thing. See the same case, in the case of benzene, I will explain with the same formula. The benzene. So the canonical form of this benzene can be written like this. So now the bond order is equal to how many bonds between carbon and carbon. So between this carbon, and let it be 1, 2, 1, 2. Between 1, 2, I have 2 bonds, and here 1, 2, I have 2 bonds. So the total number of bonds is 3, and the total resonating structures is 2. So the bond order is 1.5, what we got in previous case by using a formula. Bond order is equal to 1 plus number of pi bonds by number of sigma bonds. Similarly, I am taking one more example, nitrate ion, NO3 minus. So the possible resonating structures I am drawing now, and double bond O, so total I have 3 resonating structures here. So the bond order is between nitrogen and oxygen. Let me take this one. 2, 3, 4. That is, the bond order is 4 by 3. 1.33. So like this, we can calculate the bond order.